Okay, so let's put a few more things together here to finish up 9.1. And let's just work a few problems, and hopefully then that'll let you complete this section. There's a lot in it, that's for sure. Okay, so let's look at page 487, number 87. It asks us to square this quantity here. Well, I always want to look to see if I can simplify first. For example, 98 is the same as 49 times 2. So I can apply the radical, remember, to each of those individually. So the square root of 49 is 7, and that escapes, in other words, the radical, and I still have root 2, 7 root 2. So now I've got 4 root 2 minus 7 root 2 squared. Well, 4 minus 7 is negative 3, and remember we keep the root 2 the same since they have the same radical structure. Now we can combine 4 and negative 7 there. Okay. Then, when I go to square these, I want to square both of them. The squared will go to both terms. Well, negative 3 squared and root 2 squared. Well, negative 3 squared is 9, and root 2 squared, well, the squared here just undoes the square root that's the index, and so it's just 2. The square root of 2 squared is 2. So 9 times 2 then is 18. Okay, so we always want to look to see if we can, say, simplify a radical and maybe combine it with our other one there. Okay, so always look to simplify first before we try and do any of the other operations. Okay, let's look at another one. Okay, and on 487, sometimes we have to just take some value, for example, x equal to 4 here, and plug it in. So that would be r of 4, which means I'll take it and I'll plug it in for every x. 3 over 4 over 3, and really my radical should come all the way down there. 4 squared plus 6. Notice when x equals 4 here, it substitutes in for every x in the function, okay? Okay, so that would be the square root of 12 over 4 squared is 16, and then 16 times 3 is 48. 48 plus 6, well, that would be the square root of 12 over 54. And then I would look for any perfect squares maybe hiding in there. And so, for example, on this one, I'd say, well, that's the same as 4 times 3 upstairs. 4 times 3 is 12, and 4 is my perfect square that'll escape. And then I've got maybe 9 times 6. So then remember, the square root of 4 is 2. That escapes. Root 3 is left underneath. And then 9 escapes, and root 6 is left underneath. Well, remember I have to rationalize when I have a radical in the denominator. Okay, so let's rationalize. So that's times. Now, when I multiply, I don't multiply by 3 root 6 top and bottom, just what's under the radical there. Okay, so that would equal now 2 root 18 over 3 times the root of 36, and the root of 36 is 6. 3 times 6, so that'd be 2 root 18 over 18. Now, then I want to cancel where I can. And that would be 1 and 9. And then the square root of 18 is actually 9 times 2. So the square root of 9 is 3. So now I'm left with 3 root 2 over 9. And then I can cancel 1 and 3. So root 2 over 3. Okay. So notice, once I plug in here, I still have a little bit of, say, simplifying to do. And I always want to pull out perfect squares. But then remember, if I'm left with the radical, I have to what's called rationalize, which is this step. And then if there's more simplification, I still need to do it. Notice 18, I broke into 9 and 2, and then I escaped the 3 here. Okay. And my final answer is root 2 over 3. Okay, so when you're asked to plug in, just plug in and do your best simplifying, looking for perfect squares hiding in there, and then escaping those from the radical, rationalizing, do anything we need to do to simplify our radicals. Okay, let's look at one more problem here, page 487, number 93, and let's try and simplify here the 5th root of 13 over 5x to the 5th. Well, remember, I can apply that 5th root to each individually, break it up by division and multiplication, which is really the 5th root of 5 and really the 5th root of x to the 5th. Well, the 5th root of x to the 5th here is just x, right? If I have 5 x's there, and I take the 5th root of it, well, then I just escape 1x, right? So let me rewrite what we have now. So we've got now the 5th root of 13 over x. I pulled out of the radical, so that's gone. And I've got the 5th root of 5. Okay, so now I need to rationalize because I can't have a radical in the denominator. So I want to multiply by something top and bottom that lets me escape my terms from this radical in the denominator, okay? So if I've got 1 5, I essentially need 4 more 5s, right, to get to 5 5s, so then I can escape one of them, right? So that's essentially the square root of 625, and I'll just do that top and bottom. So I'm going to take the 5th root of 625 top and bottom. Okay. Well, 625 times 5 is 3,125. So that's going to be x. Let me clean some of this up a little. X. And then 5 times 625 is the 5th root of 3,125, which is going to end up being 5, right? But I'll show that here first, right? This will become 5. Okay. And then up top, I've got 625 times 13. 8,125. So I've got the 5th root of 8,125. Okay, so that's now the 5th root of 8,125 over, well, the 5th root of 325 is 5. The 5th root of 3,125 here is 5, and then I've got an x too. Okay. So I've simplified here to the 5th root of 8,125 over 5x, and that's fully simplified. We have no radical in the denominator here. We rationalized in this step here by multiplying by the 5th root of 625 over the 5th root of 625. And I knew I needed 625 because I needed 4 more 5s to get me to 5 5s. And then I could take the 5th root of 5 to the 5th, which is just 5. Okay, and that finally lets me escape this 5 here. And then I did it top and bottom, and I'm left with the 5th root of 8,125 over 5x. Okay, so sometimes these simplification processes get a little interesting, and I just want you to practice going through them and getting used to trying some of these. And if we have questions, we can work more of them in our Zoom meetings. Okay, thank you.